Use the long division algorithm to determine the quotients. So in lesson 3, instead of using the reverse tabular method to divide, we're going to use the old school long division algorithm that you learned back in 4th grade, except instead of just numbers, there's going to be polynomials in there. So we're dividing 2x cubed minus 13x squared minus x plus 3. We're dividing that by 2x plus 1. So we say, what times 2x is 2x cubed? We can kind of ignore that one for now. What times 2x is 2x cubed? Well, x squared. I'm going to move this all down a little bit. So x squared times 2x is 2x cubed. So now we take that and we multiply. X squared times 2x, well, we decided that would be 2x cubed. And then don't forget to distribute it to that 1. X squared times 1 is 1x squared. Then the next step is to subtract. And the way that we subtract is we change our signs. We distribute that negative 1 through and we subtract. Those add to 0. And you're left with negative 14x squared. And you restart the process by bringing everything else down. And we start all over again. What times 2x is negative 14x squared? Well, negative 7x times 2x is negative 14x squared. And then distribute that to the 1 minus 7x. And then we subtract. How do we subtract? We change our signs to subtract. Well, they're negative, so now they're going to become positive. Those add to 0, and I'm left with 6x plus 3. And we start over. What times 2x gives me 6x? Well, 2x times 3 is 6x. 3 times 1 is 3. Change my signs to subtract, and my remainder is 0 as we expected. So that quotient is x squared minus 7x plus 3. Those are the factors of our dividend 2x cubed minus 13x squared minus x plus 3. So the two factors of that right now are 2x plus 1 and x squared minus 7x plus 3. But that's the answer of the division problem there. So it's the old school long division algorithm, except there's x's in there and you have to apply that distributive property. Next one. I'm dividing 3x cubed plus 4x squared plus 7x plus 22. I'm dividing that by x plus 2. And of course I didn't leave myself enough room again. Just sliding down there. Okay. What times x is 3x cubed? Well, 3x squared times x is 3x cubed. Multiply that through 3x squared times 2. Well, that's 6x squared, positive. But I need to change my signs to subtract. Those add to 0. I'm left with negative 2x squared, and I'm going to bring the next term down. You can bring the 22 down or not. I normally just bring everything down, but you don't have to. And we start the process all over again. What times x is negative 2x squared? Well, negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. Change the signs to subtract. Positive, positive now. We get 11x plus 22, and we start all over again for one more time. What times x is 11x? Well, plus 11. 11 times 2 is 22, which means I have a remainder of 0. So my quotient, my answer is 3x squared minus 2x plus 11. And we like remainders of 0 because that means these are the factors. X plus 2 and that quotient are both factors of the dividend. Given f of x and h of x, express f divided by h. So I'm doing the f function divided by the h function in standard form by using long division. So it's just a division question worded in some more complicated way where they just use function notation. So they asked, in this case I'm asking you to practice long division, but normally I don't force you to pick a method. If you like reverse tabular and you're like, I hate this long division stuff, use reverse tabular, but for this lesson I'm asking you to long divide. But our warning light's going off, warning, 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 because what normally comes after an x cubed term? Not x, an x squared term, so I have to add in that placeholder. Do not forget to add in that placeholder, otherwise everything falls apart, just like it would if we were to do this using the reverse tabular method. So warning, 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 you gotta have your placeholders. Then we can go back to our 5x plus 21. Okay, so long dividing. What times 2x is 4x cubed? Well, 2x squared times 2x is 4x cubed. 2 times 2 is 4. X squared times x is x cubed. I have to distribute that through. Oh, that's why I needed a placeholder so things line up there. Change my signs to subtract. That's a negative 6x squared. And bring everyone down. Start the process all over again. What times 2x is negative 6x squared? Well, negative 3x times 2x is negative 6x squared. Multiply. Change my signs to subtract. I get 14x plus 21. I need to get 2x. What times 2x is 14x? Well, 7x times 2x is 14x. 7x times, oh, not x, no x there, just 7. 7 times 2x is 14. Don't do what I just did. Do it correctly, please. 7 times 3 is 21. Change my signs to subtract. And here's the thing. I was being careless there. I'm not paying 100% attention to this, which is very easy to make mistakes if you long divide quickly. And if you make one mistake in the middle of this, the whole thing explodes. So be very, very, very careful when you're dividing that you're not making mistakes, because it throws off the entire problem. So what's f divided by h? Well, what's our quotient? 2x squared minus 3x plus 7, which means that's a factor of that, as is 2x plus 3. We can say 2x plus 3 is a factor. Why? Because we have a remainder of 0. We like remainders of 0, so that means we have factors, which is going to be the big end goal at the end of the unit. 18 lessons? So 15 lessons from now, everything gets put together in one big, beautiful lesson, and you're going to say, oh, that's why we spent all the time doing this. Hopefully you do, at least. We'll end with number 3 here. Given q of x equals 3x cubed minus 4x squared plus 5x plus k, determine the value of k so that 3x minus 7 is a factor of the polynomial q. Explain your reasoning. So if 3x minus 7 is a factor, when we divide q of x by 3x minus 7, we want a remainder of 0. We like remainders of 0. Remainders of 0 means that we have factors. Let me just write 0 using words. So let's divide. I've got 3x minus 7. And there's my dividend. And we do the long division algorithm. You could do reverse tabular here, but I'm doing long division because this is the long division lesson. So I've got x squared. X squared times 3x is 3x cubed, like I wanted. Multiply, I get negative 7x squared. Change my signs to subtract. Those add to 0. And then I bring them on down, bring them on back. What times 3x is 3x squared? I need an x there. X times 3x is 3x squared. X times negative 7 is negative 7x. Change my signs to subtract. I get 12x plus k. And I start the process over again. What times 3x is 12x? Well, I need a 4 there. Positive 4 times 3 is 12x. 4 times negative 7 is negative 28. Change my signs to subtract there. So what does k have to be? I want that to magically be 0. So for this to be 0, what plus 28 gives me 0? K has to be negative 28, because negative 28 plus 28 gives me 0. So k would have to be negative 28 for that to be a factor. Explain your reasoning? Well, if it was a factor, then we divide by 3x minus 7, we want a remainder of 0. There's my explanation there. Remember, to explain your reasoning, I need words, and more than words, I need full and complete thoughts. that explain your mathematical reasoning using words, vocabulary such as factor, remainder, remainder of zero. Please just don't write random words down. They have to be full and complete thoughts. Hopefully long division did not scare you away. It will come back where the remainders will not always be zero. So for now, it's nice. If you get remainders of zero, that's what you should be getting. But towards the end of this unit, the nasty remainders will sneak in and we'll learn how to deal with that. But that was lesson 3. Get ready for lesson 4.